Okay, now we're going to do some actual graphing, and there's only 2 of them you have to do. I don't believe in giving big, huge assignments for graphing. Okay, now I'm going to be picky about how you do arrows, though. So, cubed root. The cubed root, the domain's unrestricted, but you got to pick the right number. So 1, 8, 27. By unrestricted, I mean it's going to have negatives and it's going to have positives in the domain. You don't need to rewrite anything because you have just the single variable under there. So now you plug that in. So negative 3 times 27. You got to tell your calculator it's a third root by taking it to the 1/3 power. And that gives me negative 9. Okay, now with 8, negative 3 times 8, we got to tell our calculator that it's the cubed root of 8. So there you go, negative 6. Okay, I did figure out, though, maybe some of you probably already knew it, that you could do the cubed root of 8 by going second. Yeah, I don't really know how you do that, though. There's probably a way. It should be. I don't know it. Just take it to the 1/3 power. 0, and then it goes 3, 6, 9. Okay, so we got to go by 5s on the x. So 5, negative 9. So 5, 10, 15, 20, 25, 27. And then we're going to count by 2s. 2, 4, 6, 8, and then 9's right there. You could probably go by 1s, but that's fine. 8, negative 6. So 5, and then here's 8, 2, 4, 6. Is not going to, 1, negative 3, so 1, remember you're going by 5, so negative 3, 2, and then right there. 0, 0 is just on the origin. And then what happens is you get what's called a reflection. So you go left 1, left here, then 2, 3. You got to remember you're going by 5s. Negative 8, 6, so negative 5, and then here 2, 4, 6. And then negative 27, 9, so 5, 10, 15, 20, 25, 27, then 2, 4, 6, 8, and then right here. Okay, now you make the points in the order you graph, and you're going to put arrows on both ends to tell yourself that the domain's unrestricted. You can go on all directions, positives and negatives. Okay, now you're dealing with square roots, but you only want the x inside the radical. We will deal with the +4 later, but I'm just going to take that out for now. So we're dealing with a square root now. So now it's 0, 1, 4, and 9. But then we need to stop because we can't place negatives in square roots. Those are not perfect squares. There's no way you can get... Because you can take negative 2 times negative 2 times negative 2. It's negative 8. But negative 2 times negative 2 is no way going to be 4. Or negative 2 times negative 2 is not going to be negative 4. Okay, so 4, and then we're going to put 9 in. Take it to the half power, or you can do it in your head would be better, but 6. Okay, now 4, input the 4, but it's a square root, so you got to do a half power, then minus 6. 2. Okay, so now you know you're dropping by 4 every time, so it's negative 2, negative 6. Now the +4, we need to minus 4 to compensate for that. So 9 minus 4 is 5. 4 minus 4 is 0. Negative 3, negative 4. Okay. Now here's what you want to do this. You want to graph this appropriately. Okay. So you want to graph this point first because that's your stop point. Negative 4, negative 6. So left 1, 2, 3, 4, down 1, 2, 3, 4, 5, 6. And then you label that your stopping point. You will not have an arrow on that side. Negative 3, negative 2. So I go left 3, down 1, 2, 0, 2. And then 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, so no, you connect them, but only an arrow on this side. Because the domain's unrestricted with the positives for the x, but with the negatives, you get to a certain point where you can't go past it, because then you'll end up getting negatives in the square root. As you can see, the domain restrictions, the x is -4. That's the very last x you can have and not have that square root be negative, because -4 plus 4 is 0. Okay, next up. Again, square root here. Okay, I don't need to rewrite anything. Okay, so I'm good with that equation the way it is. Square root and then stop. Okay. If you put a 9 in, the square root of 9 is 3. 3 times 5 is 15. Square root of 4 is 2. Multiplied by 5 is 10. And then you can see you get 5 and 0. Okay, you're good. You didn't have to take anything out, so you're good with this. So we need to probably go by ones on the x. So 0, 0, the origin's there, but that is your stopping point. 0 is the very last x you can have in and have it be an actual functioning equation. 1, 5, so right 1, then up 2, 4. Got to go by 2's because we got to hit 15. 4 and 10, so 1, 2, 3, 4, 2, 4, 6, 8, 10. And then 9, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 2, 4, 6, 8, 10, 12, 14, 15. Okay, and so there you go. Arrow on that end, but not on the stop. Okay, and the last one we're going to take a look at is another square root. Okay, I don't want that -3 in there, so I need to write a new equation without the -3, and then I'll end up bringing it in. The reason I like to do it this way is because people then can see how it works, kind of. Maybe I'm failing at it, but I don't know. So we're going to only pick perfect squares. So square root of 9 is 3. 3. If you're going to put in your calculator, you got to take it 2 times 9 to the 1/2 power plus 2. Or you can take square root of 9 mentally is 3 times 2 is 6 plus 2 is 8. Square root of 4 is 2. 2 times 2 is 4 plus 2 is 6. Then you got 4 and then 2. Okay, so now we got to remember that -3. So I need to cancel the -3 by plussing 3. And you can always tell if you're doing this right, because if you put 12 in for x, if you -3, are you going to get the 9 that you started with? Yes. Then you know you did it right. If you put 7 in, 7 minus 3 is 4. Did you get the 4 that you started with? Yes. Okay, so this is what I'm graphing. And by the way, this is stop down here, because you can't have negatives go in there. Okay, so 3, 2, 1, 2, 3, and I need to go by twos on the x. Okay, so 2, 3, then 1, 2, and that's a stop. Okay, that's your stop. 4, 4, 1, 2, 3, 4, or no, 2, 4, and then 1, 2, 3, 4. 7, 6. 2, 4, 6, and then 7. 1, 2, 3, 4, 5, 6. And then 12 and 8. So 2, 4, 6, 8, 10, 12. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay, that's a stop. So it shifted because of that -3. Okay, then you have those two to do on your own.